example 3 in your note guide, part A, it just says to solve the triangle. So we're going to focus right there. So just on this info. There it is. Okay. All right, so first you look at the given info. You want to jump in and start solving, but you have to stop yourself for a minute and think, what kind of information are they giving me? Do I know that this for sure builds a triangle? Check some quick things, and then if you have to, check some more complex things. So first of all, when we look at the given information, what kind of situation is this? Angle, side, side. So that kind of like the one that's not for sure thing, right? So then I look at it and I look for like the two things right away that would tell me that there's like a triangle or no triangle. I look at the side across from the given angle. Is it the biggest side? No, bummer. Okay, I'm actually sad because that means I have to do more work, right? Then I look at the angle. Is the angle making it so that we know that should be the biggest side of the triangle? In other words, is the angle 90 degrees or bigger? No. So now I have to actually like go check the minimum height requirement because I'm in that like position where it's angle, side, side, and there's nothing they're giving me that like tells me anything right away. So I want to compare 13 to 16 times the sine of 42. And I want to see what happens. If 13 is smaller than that minimum height requirement, I have no triangle. If it's exactly equal to it, I have 1. If it's bigger than it, I have 2 because I already made sure that I'm not the cases where it's like so big that I just have 1. So 16 times the sine of 42 is 10.7. 13 is bigger than 10.7. This tells me that in this scenario, I have 2 triangles. All right. So now I need to process. I am going to have 2 answers to this problem. I'm going to have a list of measurements that could build it one way and a list of measurements that could build this triangle a different way. So I have to process, like, where do I even start getting these measurements from? What does it look like? So for me personally, I want to draw a picture like we did in the notes yesterday for the analysis of how it would look when there's 2 triangles. I want that picture. For myself, I like to draw it the same way every time. I kind of already told you guys that. I like this setup where I have a fixed side right here. Like this is a side that they're giving me the measurement of. I like to make the bottom side the side that I like draw ridiculously so I know that I don't know exactly its length and that this angle is fixed. Okay? So what angle did they give me? They gave me angle A. So that's going to make this label of my triangle be called A. This angle is 42 degrees. What side lengths would surround angle A if I'm using A's, B's, and C's? B and C, because side A would be across from it. Which side length did they give me out of B and C? B. I want that to be my fixed length. That is a measurement they gave me that I cannot change, okay? So that is making this my 16. The A is across from the angle, and what we kind of did last time was we said there exists this minimum height requirement that would be perpendicular. We know that this side A can be put 2 different ways in here. So one option is that it's longer than that minimum height requirement, so it slants in like this and connects right here. Okay, that's like option 1. Option 2 is that it could slant out here because remember there's no requirement for the length of that third side of the triangle, and it could be out here like this. Okay, so those are my 2 different options. Okay, and you guys don't have to set the drawing up like this every time. Spatially, for me, sometimes I struggle with setting it up, so I like to draw it the same way every time and then move the triangle information to fit my drawing. If you have really strong spatial abilities, that might not be an issue for you. Okay. Is everybody okay with our setup here? That we found out it was 2 triangles based on how we learned how to analyze yesterday, and that we know that in general that would look like this as our 2 options, okay? Since there's 2 solutions, I literally want to take those 2 options and split them up like I'm doing 2 problems. So that's going to be my next step. Now that I have a visual of what's happening, can you take those 2 things and make it 2 triangle problems that you are solving, okay? So I'm going to have like an option 1 and an option 2, and I color-coded mine on purpose so that I could try and help you guys see where they're coming from. So my option 1, and on the note guide, if you guys need space to the right, that part B is going to be like real quick. You guys will see in a minute if we do it. So like you guys can take up all the space into there, okay? So option 1 is the triangle that I put in the blue side A, okay? So it had this set side length B of 16. And then A came in like this at 13, which made C this smaller side over here, and angle A was over here at 42 degrees, and that makes this angle B and this angle C. So there's my option 1. Okay. My option 2 is completing the triangle with that green side A that I drew. And so option 2 looks like this. It has that fixed side length of B at 16, but side A went out like this to form the triangle, making side C a little longer. And here was still my angle A set at 42 degrees, and that makes this angle B and this angle C. Is everybody okay with how I split it apart? So I went back to our analysis to understand how the drawing fit together. And then I'm taking it and I'm pulling apart my 2 different options. So I'm saying, I know how to solve one triangle. So let's turn the 2 triangle situation into like 2 problems, okay? Look at each problem though. It's kind of a little silly once we start diving into it. Let's say I said, okay, what if I was gonna solve option 1 first? What equation would I set up to start solving option 1? Okay, so we would use law of sines, right? And what would the equation say? It would say sine of 42 over 13 equals sine of B over 16. Now look at option 2. Let's say you're going to set up to solve that one. What would the equation say? It would say sine of 42 over 13 equals sine of B over 16. So good news and bad news. Good news is there's only one place to go from here. I need to set up sine of 42 over 13 equals sine of B over 16. The bad news is I don't even know which triangle that's solving for, okay? So I'm going to set up sine of 42 over 13 equals sine of B over 16. How are we going to know which triangle this is for? Luke?
Option 1,
Mm-hmm.
B is like B greater than 90.
Good.
So it would work.
Good. Okay. So do you guys see what Luke is saying? In option 1, B is greater than 90. And I know there's some hesitation when we draw things to be like, drawings aren't to scale. And you're right. My drawing is horrible. It probably isn't to scale. However, I do actually know that in option 1, B is obtuse. The reason that I know it's obtuse is remember where option 1 came from? It came from our drawing of these 2 triangles over here, right? See where that perpendicular line was right here? So I actually do know that that angle B is obtuse because the way I drew the line, I drew it at this slant from the 90 degrees, which means it actually made that smaller and this one bigger than 90 degrees. Does that make sense to everybody? So though my drawing is not to scale, I do know that what Luke said is true, that in option 1, angle B is obtuse, and in option 2, angle B is acute. So let's solve this angle B, and if it's acute, it clearly belongs to option 2, and if it's obtuse, it belongs to option 1. Is that okay with everybody? All right, so see what you get for angle B, and I'll do the same. You guys should multiply both sides by 16 if you're a little unsure what to do here. I'm not really going through the solving process as thoroughly because you're supposed to have done stuff about this already. Your last step should be to take the inverse sign to get B out of the sign. Okay, and if I'm going a little fast in the solving, stay with me in the problem. You guys will get to try solving one on your own at the end, okay? So if you're like, I didn't have time to find angle B, trust me that this is angle B and follow me through the steps of the problem. I'm assuming you can solve these equations based on homework 3 work, okay? So I get the angle B is 55.4. So which option does that belong in? Option 2. This is 55.4. So I'm going to make a little list over here. To finish solving this triangle, I need angle B, angle C, and side C. And right now I actually know that angle B is 55.4 degrees. And I'm like ready to roll on this triangle now. Are you guys good? Like, can I just keep going over here? So I'm going to like continue like I would if there was one triangle. And I'll get back to what to do with the other one in a second, okay? So to get angle C, we would add up our 2 angles and subtract from 180. So we'd do 42 plus 55.4 minus 180. And we get that third angle of 82.6. So this angle C is 82.6 degrees. And then how am I going to get side C in this triangle? Law of sines, right? I could just keep using it every time I have that ratio. So I'm going to set up sine of 42 over 13, again, because I like that ratio. It's nice and complete and was given to me. But this time I'm solving for side C, so I want that in the equation. And side C is across from angle C. So that second ratio will say sine of 82.6 over C, okay? And then I'm going to cross multiply and solve to get C alone here. Again, if the solving is too fast for you, wait till you're trying the one on your own, and you'll see if you have an issue with the solving. But stay with us with the thinking behind this type of problem. So I get that C is 19.3. Okay. This is one part of my answer. My answer has two parts to it. This is one way that you could build a triangle with the given information that they said. Okay. When you give me your answer, I want it in two parts. I either want two triangle pictures with everything filled in, or I want two separate lists. If you just give me a bunch of angle B's, angle C's, and side C's, I'll give you some credit, but I won't give you all the credit because I don't know if you totally understand which triangle they belonged in and what the options are. Does that make sense to everybody? Okay. And I don't know how to visually see that understanding without that separation between your answers. So now we're a little bit stuck, right? If we set this up again, we're just going to keep getting 55.4. We know that 55.4 is not angle B in the second triangle. So I'm going to take you back to our original drawing of the two triangles, and we're going to try and find some geometric relationships between this angle B and this angle B. So since law of sines isn't going to give me the answer I want, I'm going to see if there's anything I know about geometry that reveals to me some relationships between these angles. Does that make sense to everybody? Okay. So I'm going to go and I'm going to zoom in right here on this guy. So that's as far as it will let me go. So there we go. All right. So acute angle B right here, 55.4 degrees. Okay. Now, we drew this triangle, and have you guys ever done those puzzles? Like, how many squares are in this drawing? And it's like squares within squares within squares. There's a third triangle in this picture that we were ignoring because it's not really a triangle we want to solve, right? It's not one of our options with all of the information, but it does reveal to us some geometric properties of how things are related to each other. So here's the third triangle in the picture. And no, we don't want to solve that triangle. That's not something from our given information, okay? However, this third triangle is the key for me to figure out how the relationships between things. What kind of triangle is this triangle that I highlighted? Is isosceles, right? This is 13 and this is 13, which tells me that this is 55.4, but also this is 55.4. How does that help me with trying to figure out obtuse angle B over here? Okay, Payne?
Subtract 55.4.
Is that all right with everybody? So this obtuse angle B over here in option 2, though the law of sines can't find it for me, it is always supplementary to the acute angle B because of this relationship. Every time I set up these two triangles, this acute angle B is the same as this little angle over here that's supplementary to the obtuse angle B, okay? So every time I find acute angle B, its supplement will give me the obtuse angle B. Okay, so to find angle B over here, I'm going to do 180 minus 55.4. Okay, and that gives me 124.6, right? Check my arithmetic if I'm wrong. So for option 2, I need to find the same pieces of information as I did in option 1. The angle B for this option would be 124.6. And now, just like before, once I have that second angle, I'm ready to roll. I can figure the third angle out, knowing that all the angles of a triangle add up to 180, okay? And then I can use law of sines to get me through the rest of this problem. So I'm going to take 124.6 plus 42 and subtract it from 180. That's going to give me 13.4. So this is 13.4. And now to find side C, I'm going to set up law of sines, okay? And it will say sine of 42 over 13. Again, I keep using the same ratio that I know and was given. And it's going to be equal to sine of that very small angle C over side length C. Okay? And then you guys are going to cross multiply to solve. I'm going to tell you what I get. Again, if you can't keep up, just wait a second because you'll do your own and we'll check the solving then. And so we get 4.5 should be what we get.